Welcome back to the deep dive. Today, we have a really crucial mission. We're going to try and master the conceptual landscape of Azure. We've pulled together a whole stack of these advanced scenario-based challenges, the kind that can trip up even pretty experienced architects. And our goal is to just pull out the core, the unshakable rules of how Azure actually works, governance, identity, all of it. So if you're prepping for a certification, one where you need to make those fast, high-stakes decisions, or if you just want to make sure your production cloud is built right from the ground up, this is for you.
That's really the heart of it. We're deliberately trying to move past just simple definitions. This is all about forcing that deep conceptual understanding, which, let's be honest, is the only way this stuff really sticks in your memory, especially when you're facing a tough technical assessment. When you're looking at some complex, multi-layered problem like, I don't know, balancing departmental billing with a unified security policy, you can't just rely on memorizing terms. You have to actually get the hierarchy, the real purpose of each service, and what the architectural impact of every choice you make is.
Exactly. So we're going to try and provide that mental framework to make the right call every single time.
Right.
Think of it like this. We're translating the super technical Azure docs into, memorable, actionable insights. We're going to cover 15 critical scenarios today, spanning everything from identity to the governance stack, the resource model, and how you engineer real resiliency. And our mission, for you listening, is to highlight not just the right answers, but why the common, the seemingly logical assumptions, what we're calling exam traps, will lead you down a very wrong and often very expensive path.
I like that. We're giving these technical requirements a narrative. Understanding why a management group is the only real tool to solve a multi-subscription governance problem, or how a managed identity just completely eliminates the credential nightmare. That makes the concept stick so much more effectively than just reading a definition on a page. So yeah, let's make these foundational concepts unshakable.
I love that framing. Okay, let's start right at the very top of the cloud hierarchy. Let's talk about control. Our first big pillar is establishing the governance stack. How management groups, policies, and resource groups define control and compliance for an entire enterprise. So we dive right in with scenario 1, which tackles that fundamental question of scale. Imagine a big enterprise. They have one central Entra tenant, but they've got dozens of production subscriptions for all the different business units. And the mandate from the top is crystal clear. We need to consistently enforce our security standards across all of our production subscriptions, and we can't be doing it manually.
And this is just a classic test of whether you understand Azure's hierarchy. The most common wrong answer we see, and it's a disaster administratively, is what we call administrative sprawl. Architects will wrongly assume they have to treat every subscription like its own little island. So they go into subscription A, apply policy set X, then they go to subscription B, apply the same policy set X, and so on.
And that's where the cost, not just in money, but in overhead and the risk of policy drift just explodes, right?
Yeah.
If you have 30 production subscriptions, you are literally managing 30 separate copies of the same policy. So if you have to update that policy, you have to remember to do it 30 times.
Precisely. And that is completely unsustainable. It introduces this immediate risk of what we call policy drift. That's where one subscription accidentally misses an update. And that could lead to a regulatory audit failure, or even worse, a critical security hole. When auditors come in and find that your governance is inconsistent across your cloud footprint, that is a massive red flag. The real cost here isn't just the time, it's the risk of non-compliance and potential data leakage.
Okay, so if that manual approach is so burdensome and risky, what does the correct architecture look like to address this?
The right architectural move is to immediately centralize. You use the highest level of control you have in the Azure hierarchy. You create a dedicated management group, let's call it, prod MG. Then you place every single one of your production subscriptions underneath it. And here's the crucial part. You assign that mandatory security policy just once to that management group.
And this is where it gets really important to remember. Why is the management group the definitive answer, architecturally speaking? Why does that work?
Because the management group sits hierarchically above the subscription. It's really the only scope that can enforce governance across multiple distinct billing containers. When you assign a policy at that level, it inherits downwards.
Like that waterfall you mentioned earlier.
Exactly. It flows down to all the child management groups, all the subscriptions under those, and then all the resource groups and every single resource within those subscriptions. That single point of assignment guarantees absolute consistency. It completely eliminates policy drift. This is the bedrock of any solid enterprise governance design.
Okay, but let's play skeptic for a second. No enterprise is perfectly uniform. What if there's one specific production workload in one subscription that needs a temporary, totally valid exception to that policy? Do we have to break our beautiful prod MG structure?
No, absolutely not. That's a critical point. You have to maintain the integrity of that core governance model.
Mm.
If you start messing with the MG level policy, you're now affecting dozens of other subscriptions that didn't need that exception. So instead, you use the built-in flexibility mechanism, policy exemptions. You apply the exemption, usually with an expiration date and a business justification, at the lowest possible scope. So on the specific subscription, or maybe even the resource group that needs that deviation.
That's such a key distinction for remembering this. The core rule policy assignment at the MG is sacred, but the flexibility, the exemption, is handled at a much lower scope.
This is a guaranteed differentiator on a technical assessment. If the scenario explicitly says, and you'll see these key words, centralized security across multiple subscriptions, the architectural answer is always to use management groups. Anything else is just a flawed, high-maintenance design.
Okay, let's move on to scenario 9. This one focuses right on the mechanism of enforcement itself. We've got a team of developers, they're super productive, but they keep deploying resources, storage accounts, app services, in regions that violate the company's guidelines. Maybe those regions are too expensive or they don't have the right regulatory coverage. This is governance drift in action.
And this really highlights the huge difference between human processes and actual technical controls. The wrong assumption here is that you can fix this with, soft measures.
Like writing stricter documentation.
Right. Or refining naming standards, or running yet another mandatory training session. Look, documentation is necessary, but it doesn't stop a simple, accidental click on the wrong region in a drop-down menu during deployment. If the Azure API allows it to happen, human error will eventually make it happen.
We need a technical block. We need the cloud platform itself to just say, nope, you can't build that here.
Exactly. The solution has to be technical enforcement. So the correct action is to assign an Azure policy. Specifically, you'd use a built-in one like allowed locations, and you scope it at the management group or subscription level where these developers are working. And crucially, you configure that policy to use the deny effect.
Let's dig into that deny effect a little. Why is policy such an effective tool against this kind of drift?
Because the policy actively prevents the non-compliant deployment from ever succeeding. It happens at the resource manager layer. So if a developer tries to deploy a virtual machine to, say, Southeast Asia, and your policy denies that location, the deployment just fails. It gives them a clear error message before a single dollar is spent. This ensures operational consistency, it blocks resource creation where it's not allowed, and it just instantly eliminates that geographic drift. It's automated compliance.
That's incredibly powerful. And policy can do more than just deny, can't it? What if I just wanted to track compliance for now without actually stopping deployments yet?
Right, the policies are very flexible. You could use the audit effect. That would just report on existing resources that are non-compliant without blocking anything new. Or you can get even fancier. You can use modify or deploy if no exists, which we call DIEF, to automatically bring resources back into compliance. That's called remediation. So for instance, if a dev forgets to enable monitoring on a VM, a DIEF policy could just automatically deploy the necessary monitoring agent for them. But when the problem statement is about explicit prevention of costly or non-compliant actions, the deny effect is the one you have to choose.
So the lesson to lock in here is clear. If the problem mentions drift, inconsistent deployments, or the need for a technical veto, the answer is Azure policy. Things like naming standards or locks, they just don't have that kind of enforcement power.
Let's move to scenario 8, which deals with an architect's worst nightmare: accidental data destruction. So a critical production storage account was accidentally deleted. It was deleted by an authorized team member, someone who had the necessary RBAC permissions during some routine maintenance. Now the question is, how do we guarantee this never happens again?
This gets into the subtle but really profound difference between authorization, which is RBAC, and administrative protection, which is locks. The wrong assumption is always trying to solve this just with RBAC. People think, oh, I'll just remove their deletion rights.
But what if the user is a contributor? Or, worse, an owner? And they often need those roles for maintenance or troubleshooting. Those roles inherently have deletion rights. RBAC governs who can do what based on their role. But if the user is authorized to delete, RBAC offers no safety net against human error when they're having a bad day and click the wrong resource name.
So if RDAC is the authorization layer, what's the mechanism that adds that necessary friction, that administrative override?
The correct action here is to apply a resource lock, specifically a cannot delete lock. You can apply it at the resource level, so right on the storage account, or on the resource group that contains it. A resource lock is an administrative safeguard that operates outside of the normal RDAC check. It's an explicit barrier that even an owner has to manually remove before that destructive action, the deletion, can actually go through.
And that moment, that extra step of having to remove the lock, that's the key safety net. It forces a cognitive pause. Hang on, why do I have to explicitly override this lock?
Exactly. It prevents that instantaneous, irreversible mistake. It adds friction right where you need it. And we have to be really specific about the type of lock. You must use cannot delete. This is a crucial distinction that often comes up in scenario questions.
What's the problem if we accidentally choose the read-only lock instead?
Well, if you apply a read-only lock, you do prevent deletion, which is good. But you also prevent all modification actions. So that means you block critical maintenance, like updating firewall rules, applying configuration changes. You might even stop the OS inside a VM from installing patches. You'd essentially cripple the asset for day-to-day operations. The cannot delete lock specifically targets only the deletion command, and it allows all other necessary updates and maintenance to happen without any issues.
The exam trap here is crystal clear and it's really memorable. If the problem is about accidental deletion, the answer is a resource lock. If the problem is about unauthorized access, that's when you talk about RBAC.
All right, let's move on to the resource group itself in scenario 3. So we have a team. They've meticulously separated every single one of their applications into its own resource group, and they believe that this separation automatically enforces security boundaries. They're proudly saying, we put each app in its own RG for security, so App Team A can't touch App Team B's stuff.
This is such a core, fundamental misunderstanding of the cloud resource model. While RGs are absolutely essential for organization, they are not, by themselves, a security mechanism.
They are purely logical containers. Their primary intended purpose is lifecycle management. They're the scope for deployment, for grouping resources, for billing reports, and most importantly, for deletion. If you delete the RG, everything inside it is gone. The critical wrong assumption is believing that just creating a resource group provides any kind of built-in security isolation. It just doesn't.
So if the resource group itself gives you zero security, where does that security isolation boundary actually come from?
It comes entirely from role-based access control, or RBAC. So the correct action is to assign RBAC roles explicitly at the resource group scope. For App Team A to manage App B's resources, you assign them the contributor role, or whatever is appropriate, only on App B's resource group. If you don't do that explicit assignment, a user who is a contributor at the subscription level can still access resources in every single RG inside that subscription.
So the RG is just the box you apply the security policy to. It's passive.
Exactly. You could have a beautifully named resource group, but if you don't have a properly configured RBAC role assignment on it, it provides no protection at all. And this is a really important thing to remember, because when a question implies RG-level isolation, the real architectural answer is always RBAC assignment at RG scope.
Okay, we've established the governance stack. Now we need the key to get into that stack, identity. We're moving into the area that causes, I think, the most foundational confusion for new cloud architects. That relationship between identity, which is Microsoft Entra ID, and the financial and resource structures, which are subscriptions.
Scenario 2 is the perfect example of this confusion. A new developer asks for a second, totally separate subscription, and they believe it's required to create a separate identity boundary for their isolated workload.
Yeah, the assumption there is that a subscription is like a siloed company division with its own user directory and everything. That mindset comes from, traditional on-prem network architecture, but it just completely breaks down in Azure.
It's fundamentally incorrect. The right thing to do here is to educate the developer on the core architectural relationship. Identity boundaries are determined exclusively by the Microsoft Entra tenant, not by subscriptions.
Let's really nail this foundational rule down for everyone listening. If identity lives at the tenant level, what does that actually mean in practical, everyday terms for a user?
It means that every user, every group, every single authentication method, every app registration, every service principal, they all live in that one central directory, the Entra tenant. When you log into Azure, you are logging into the tenant. The tenant is your organization's identity root.
And what about the subscriptions?
Subscriptions are just billing agreements. They're quota containers, and they're a unit of organization for your deployments. One single Entra tenant can have dozens, even hundreds of subscriptions under it, and all of them share the exact same global identity directory. So creating a second subscription for identity isolation is pointless. They're still going to share the same users and groups unless you apply further RBAC restrictions.
So the architect's insight here is crucial. We create subscriptions for very specific functional reasons, like cost separation, for clean departmental chargebacks, quota separation, so one team doesn't hog all the resources.
Right. And lifecycle separation, dev, test, prod, and also for isolating the blast radius. If a big mistake happens in a dev subscription, it's physically segregated from the prod subscription. But that core identity plane, it stays unified. This distinction is a critical exam trap. Subscriptions organize resources and billing. Tenants organize identity. And building right on that, Scenario 7 presents the real-world enterprise requirement. The company demands cost isolation and departmental autonomy, so they need multiple billing units. But they also absolutely require centralized control over all user access, roles, and identity security.
This is where we have to balance that decentralized finance with centralized security. The wrong move here would be to suggest separate tenants for each department.
Oh, separate tenants, what we call tenant sprawl, is an administrative nightmare for a unified company. You'd lose single sign-on. You'd force users to manage multiple accounts. You'd make central auditing and security policy enforcement incredibly complicated. You'd completely break that centralized identity requirement.
So the only viable structure has to be a single identity plane that serves multiple business units.
Absolutely. The correct architectural action is to maintain a single Microsoft Entra tenant that gives you unified security, central authentication, and consistent identity policy. Then you create multiple subscriptions, one per department, one per major project, whatever makes sense, underneath that single tenant. And that's how you manage your clean billing boundaries and spending quotas.
And this structure is really scalable, right? Because all those governance rules we talked about earlier, the management groups and Azure policies, they can be layered right on top of this single-tenant, multi-subscription environment to enforce consistency, even while the departments manage their own budgets.
This is the definitive architecture for most large companies in Azure. And to connect the dots so you remember this, if the main requirement is cost isolation and separate chargebacks, the solution is subscriptions. If the main requirement is unified identity control and single sign-on, the solution is a single tenant.
Okay, now let's add some external complexity. Scenario 14, we have a merger. Company A buys Company B. They need to share resources like right now, but they both have these massive established Entra tenants. Merging those directories is a multi-year project. They need access now.
Right. This tests how we manage guest identity and temporary cross-tenant access without doing the massive, complex job of an immediate tenant merge. The wrong assumption, again, is trying to do the long-term solution merging tenants when a short-term access fix is what's needed. Tenant merges are administrative beasts. They require downtime, directory sync, reconfiguring applications. It's a huge project.
So we need a secure, federated way for users from the acquired company to keep using their existing corporate logins.
The correct action is to use the built-in cross-tenant access capabilities, specifically Entra ID B2B, which stands for business to business. Company A invites the necessary users from Company B into its tenant as secure guest accounts. Those users authenticate against their home tenant, Company B's, but they get access and the necessary RBAC roles in Company A's subscriptions.
So B2B is the path of least resistance. It's a low-disruption temporary bridge.
It's the necessary short-term solution, exactly. It minimizes disruption, and it avoids creating a bunch of new passwords and credentials for people to manage. And a critical detail here is that while B2B is for human users, if the access is needed for automated workloads, like an application from Company B needs to talk to a resource in Company A, the solution there shifts to using service principals with cross-tenant consent or configuring the application as a multi-tenant app.
The takeaway is to prioritize the immediate business need temporary access over the big architectural cleanup. If the scenario involves multiple tenants needing short-term access, the answer is always B2B federation.
Okay, our final identity scenario, Scenario 10, is just fundamental to modern cloud security. We have Azure VMs that need to authenticate to secure resources, like a key vault or an Azure SQL database. But the requirement is to prevent storing any secrets, credentials, or connection strings on the VM itself.
The old way of doing this, the highly insecure way, and this is the wrong assumption, is using a standard service principal, creating a secret for it, and then storing that secret in a config file on the VM. That's just a ticking time bomb. If the VM gets compromised, the secret is stolen.
That approach completely violates the principle of zero trust. The correct architectural solution leverages the native identity plane through managed identities. Specifically, if it's a single isolated VM, the correct action is to enable a system-assigned managed identity on that VM.
Let's break down how managed identities work without credentials, because this is where the real genius of Azure's security model comes in.
A managed identity is an identity that's registered in Entra ID, but its lifecycle is managed entirely by Azure. When you enable a system-assigned managed identity on a VM, Azure registers that VM in Entra ID as a unique service principal. The authentication then happens completely behind the scenes using token exchange. The VM requests a token from a special service called the Azure Instance Metadata Service, or IMDS. It's a non-routable endpoint that's only accessible from inside the VM. The IMDS service validates the VM and securely issues an Entra ID token that the VM can then use to authenticate to other services, like Key Vault.
So the token never actually touches the VM's file system in a way that a hacker could easily steal it. The platform handles all the complexity.
That's the critical technical detail. It eliminates secret sprawl,
Yeah.
and you don't have to worry about credential rotation because Azure handles all of that for you. It streamlines security compliance immensely.
No, we have to clarify the difference between the two types of managed identities because tests often probe this exact point. We chose system-assigned here. When would we choose a user-assigned one?
A system-assigned managed identity has a one-to-one relationship with the resource. So if the VM is deleted, the identity is automatically deleted with it. It's perfect for single-instance applications. However, if you have multiple resources, say a cluster of 10 web servers, or maybe a function app and a logic app, and they all need the exact same access rights to a shared resource.
Like a shared key vault.
Exactly. Then the answer is a user-assigned managed identity.
Because the user-assigned identity is a standalone resource.
Yes. You create it as an independent Entra ID resource, and then you assign it to multiple host resources. This lets you manage the RBAC assignment centrally on the identity itself, instead of managing permissions for 10 individual system identities. This is critical for scaling shared service access.
So regardless of the type, the main rule to remember here is mandatory. If the scenario is about getting rid of stored credentials or secrets for service access, the solution is always managed identity. All right, we've established governance and identity. Now let's pivot to the physical infrastructure, high availability, and disaster recovery. This is where we have to be absolutely clear on the scale of failure protection. Protecting yourself within a region versus protecting against the catastrophic failure of an entire region.
Scenario 4 presents the highest bar for business continuity. The requirement is that a solution must stay online and functional even if an entire Azure region, let's say East US, fails completely because of a major disaster.
The big conceptual test here is confusing intra-region redundancy with inter-region redundancy. The two most common wrong assumptions are, first, thinking availability zones can solve this on their own, and second, thinking geo-redundancy services like GRS just automatically apply to everything.
Let's take apart that first assumption. Availability zones, or AZs, are fantastic for high availability, but they only protect against failures within a single region. They guard against a single data center being taken offline by a power outage or a local network failure. But if the entire geographic cluster that makes up the East US region fails, your AZ deployment fails right along with it.
And what about GRS geo-redundant storage?
GRS applies specifically to certain PaaS services, mainly Azure storage accounts. And while it does replicate your data to a secondary region, that replication is often asynchronous. That means there's a recovery point objective delay. You might lose some data. And crucially, GRS by itself doesn't provide a way to automatically fail over your application compute layer, your VMs, or your app service plans.
So if the requirement is protection against a whole region failure, we have to go multi-region.
Absolutely. The correct approach is to deploy the workload across two distinct Azure regions, a primary, like East US, and a secondary, like West US. This requires real architectural planning. You have to use active-passive or active-active deployment models, use global load balancers like Traffic Manager or Front Door to route traffic away from the failed region, and use data services that support robust managed cross-region failover, like Azure SQL Database, with geo-replication.
Architecturally, this also adds a lot of complexity around data synchronization, which we have to acknowledge. You have to keep the data consistent between those two distant regions.
That's the trade-off. Multi-region deployments are far more complex and more expensive. You have more network latency, and you have to carefully manage your recovery time and recovery point objectives. But it is the only way to satisfy that requirement for full disaster recovery. The point to burn into your memory here is crucial. Never confuse AZ-level redundancy which is local high availability, with region-level redundancy, which is full disaster recovery. Now let's pull back a bit to high availability within a region, scenario 5. The task is to deploy a VM-based workload and make sure we use the pattern that achieves the highest possible service level agreement, the highest SLA, assuming the region supports availability zones.
This tests the choice between the older infrastructure level HA model and the modern highest tier model. The wrong assumption here would be to use an availability set.
Availability sets are important to know, but they are technically inferior to AZs for getting the maximum SLA. An availability set spreads your VMs across different fault domains and update domains. That protects you against a single rack failure or a platform update, but they usually live within a single data center or a very small cluster of them. They don't offer the geographic separation you need for the absolute highest SLA guarantee.
So if the maximum possible SLA is the mandate, where do we turn?
The correct action is to deploy your VMs across availability zones, or AZs. AZs offer superior resiliency because they are physically and logically separate data centers within the region, usually separated by several miles. They have independent power, independent cooling, and independent network infrastructure.
That physical separation ensures that a failure in one zone, like a local power failure, won't affect the other zones.
Exactly. When you deploy across 3 AZs, you're spreading your workload across 3 independent failure domains. And that architectural choice results in the highest published SLA that Microsoft offers for VM workloads.
We should also acknowledge the complexity trade-off here. It's important for an architect. Deploying across AZs means you also have to correctly configure multi-zone networking, and you have to use a standard tier Azure load balancer to distribute the traffic because a basic load balancer doesn't support zones.
That's right. The cost and the configuration complexity of an AZ deployment is higher than a simple availability set, but that cost is justified when you have to meet that requirement for maximum SLA. The critical exam trap to remember is this hierarchy of resilience. If the question specifically asks for the highest SLA and it mentions that AZs are available, the definitive answer is always use availability zones.
Okay, we've arrived at our final pillar, the practical execution layer. This section is all about how we provision, organize, and manage resources using automation, primarily through the Azure Resource Manager, or ARM. These concepts define how reliable and repeatable your infrastructure as code really is.
Scenario 6 addresses a pretty common fear for people who are new to infrastructure as code. A user modifies a template for an existing resource, maybe a virtual network, and redeploys it. The resource updates just fine, but a nervous coworker is worried that redeploying the template will create duplicates and lead to resource sprawl.
This tests the fact that ARM is not a scripting language. The wrong assumption is thinking of an ARM deployment like a shell script, where if you run the script again, it tries to create another resource with the same name and causes an error.
ARM is fundamentally different because it is declarative and idempotent. And idempotence is the architectural concept that means running the same operation multiple times gives you the same result without any bad side effects. The correct explanation here is that the ARM template defines the desired state.
So how does ARM know whether to create a new thing or just update the old one?
ARM identifies the resource using its name and its scope, the resource group, subscription, and so on. If ARM sees that a resource with that exact identifier already exists, it doesn't try to create a new one. Instead, it just compares the current state of the live resource against the desired state in your template. If there are any differences, ARM updates the properties to match the template. Duplication is prevented entirely.
So continuously redeploying the same template is not only safe, it's actually the recommended practice for ensuring your configuration doesn't drift.
Absolutely. This enables reconciliation. If a developer manually changes a setting in the portal, the very next template redeployment automatically overwrites that manual change, bringing the resource back into compliance with your codified desired state. It's a core principle for maintaining a clean cloud environment. Okay, scenario 13 highlights a specific automation failure. A deployment pipeline is crashing over and over again. It's because the system is trying to attach a VM network interface card, a NIC, to a virtual network, a VNet, but the VNet hasn't finished its own deployment cycle yet.
This tests the concept of deployment order and dependency management within ARM. The flawed assumption here is thinking that ARM processes resources sequentially, just in the order you write them in the template file.
ARM is architected for parallel processing.
Yeah.
It wants to be as fast as possible. So it will try to deploy every resource at the same time unless you define an explicit or implicit dependency. The VNet and NAC relationship is a perfect example where that parallelism fails because the child resource, the NAC, can't attach to a parent, the VNet, that doesn't fully exist yet.
So how do we force it to deploy sequentially when we need to?
The correct action is to define explicit dependencies using the depends on array inside the NIC's resource definition. By listing the VNet's resource ID in the NIC's depends on property, you are telling ARM, do not even start provisioning this NIC until the VNet resource is fully provisioned and available.
And while ARM can often figure out dependencies on its own, especially when one resource references another, that depends on property is the foolproof way to enforce a specific sequence.
Yes, and it's critical for stability. For retention, just remember that you use depends on whenever the default parallel execution would cause a failure because one resource needs another one to be complete before it can initialize.
All right, scenario 12 gets into the practicalities of automated pipelines, specifically for services like storage accounts, which need names that are globally unique across all of Azure. The goal is to deploy this automatically with no manual steps.
Manual naming just doesn't scale with automation. You're going to have collisions. The concept being tested here is using the native features of ARM templates to guarantee that uniqueness.
The correct action here is to rely on ARM template functions that are designed for exactly this. We're talking about functions like unique string or GIDs.
Yeah.
You combine those programmatically generated strings with a readable organizational prefix or suffix.
For example, you might name a storage account something like prod app name and the output of the unique string function. That combination solves both needs. The ARM function guarantees the uniqueness that the platform requires, and the human-readable prefix makes sure that operators and monitoring systems can still tell what the resource is for. The unique string is usually generated based on something like the resource group ID, which makes it deterministic within that scope.
So the lesson to remember is, when automation needs a globally unique name, the solution has to involve ARM functions. Trying to manage uniqueness manually is a recipe for failure.
Okay, scenario 15 revisits resource groups, but this time with a focus on their architectural philosophy. A team is organizing their RGs purely by resource type. So all the VNets are in one RG, all the VMs are in another, all the storage accounts in a third. They think this is tidy and improves organization.
It sounds logical on the surface, right? Grouping like with like. But it fundamentally misunderstands the purpose of the RG. Why is organizing by resource type a bad idea?
Because it completely violates the primary design principle, which is lifecycle alignment. Resource groups should be organized by application, environment, or shared lifecycle. Resources that are deployed together, managed together with shared RBAC and locks, and are intended to be retired and deleted together, they must all live in the same group.
Let's walk through an example of why lifecycle alignment is so much better than resource type alignment, especially if you're preparing for an audit.
Okay, imagine you have App X, and it's running in your development environment. It needs a VNet, 3 VMs, and a storage account. If these are scattered across 3 different resource type-based RGs, and you need to apply a high-security lock to all the components of AppX Dev, you have to manually scope that lock across 3 different RGs. And when you decommission AppX Dev, you have to go hunting in those 3 big RGs to find the 5 specific resources that belong to AppX, which just increases the risk of missing one and leaving behind an orphan billable resource.
But if they are all in one resource group called, say, AppX Dev RG, then every governance action, all your cost reporting, and the final decommissioning delete command are all scoped to that single logical container.
That's the power of lifecycle design. It dramatically simplifies management, auditing, security scoping, and resource retirement. The only real exception is for truly shared infrastructure, like a global firewall or a core network hub, which might live in its own dedicated RG. But the general rule for application components is alignment.
The retention point here is clear. If the scenario emphasizes lifecycle alignment or shared deployment boundaries, the answer is always an app-based RG structure.
And our final scenario, number 11, deals with a common operational problem. A division hits its VM quota limits in its main subscription and urgently needs to deploy more resources.
This tests the scalability model of Azure quotas. The wrong assumption is to panic. To think you have to immediately redesign your application or start moving workloads between subscriptions, those are complex secondary solutions.
Quotas are a soft limit. They're designed primarily to stop organizations from running up a massive accidental bill. They're not hard capacity limits in the physical data centers. Therefore, the correct action is always the simplest and most direct one. Request a quota increase from Azure for that specific VM family and the relevant region.
And why is that the preferred first step?
Because Microsoft's quota increase process is streamlined and usually pretty quick for standard resources. It is the path of least resistance. An architect should always prioritize administrative simplicity over a big architectural refactoring when a simple quota increase will solve the problem. Only if that request is denied or if there's a specific architectural reason to distribute risk should you then consider moving workloads.
Excellent. The exam trap is simple. Quota issues should first prompt the action. Request quota increase. That was an immensely detailed exploration. We took 15 complex foundational scenarios and really distilled them into 5 critical pillars of Azure architecture. I think that provides the depth needed not just to pass a test, but to actually architect robust cloud solutions.
We covered 1. Hierarchy and governance, where we established that management groups are non-negotiable for centralized multi-subscription policy. 2. Identity and tenants, clearly differentiating that identity boundary, the tenant, from the billing boundary, the subscription. 3. Technical enforcement, confirming that Azure policy is the hammer you use against drift, and recourse locks are the shield against accidental deletion.
4 was resiliency, where we definitively separated the local protection of availability zones for the highest SLA from the full disaster recovery you get with a multi-region deployment.
And 5. Deployment and lifecycle, where we reinforce the declarative and idempotent nature of ARM and establish that resource groups must align with the application lifecycle for effective management. This structured, scenario-based approach, it ensures you don't just remember the answer. You internalize the reason why those common pitfalls are such fatal flaws.
So, what does this all mean at an organizational scale? We successfully navigated the technical boundaries, the logical ones, which are RGs, the administrative ones, subscriptions, and the identity ones, tenants. Now, consider this final provocative thought, which moves beyond the technical and into the corporate boardroom. If billing separation is the main reason for subscription sprawl in a large company, giving departments their own budget autonomy, and then central governance is rigidly imposed from above with management groups, how might that strict, uniform policy enforcement become a source of contention? The technical structure gives you control, but imposing that control affects departmental autonomy and requires, well, political negotiation.
That's a powerful point to close on. Governance is technical, but the implications are always organizational and human. The core lesson here is that understanding the hierarchy doesn't just help you pass the test. It informs the high-level politics and the long-term viability of your entire cloud strategy.
We encourage you to review these principles and really visualize the failure scenario we outlined for each of those exam traps. Thank you for joining us for this deep dive into Azure Foundations. We hope this knowledge is now securely ingrained as your architectural bedrock.